Assalamu alaikum and welcome to SSD. So let's say you have a function f of x, and this function may be e to the power x, or it may be ln x, or anything. Okay, so in this video I want to express this f of x as this kind of simple polynomial a plus bx plus cx square plus dx cube and so on. It's an infinite series. So we want to express this f of x like this, and to do this you have to find the value of these coefficients. So in this video we will see how to find the value of these coefficients, and this is actually the MacLaurin series. At the end of the video you will see that we will find a series, and that will be actually the MacLaurin series, which is very useful to find the value of e to the power x or ln x. Okay, so let's start. Or even you can find sin x and the series of cosx, whatever you want, by using this series. This is actually the MacLaurin series. So let's start. So f of x, let's say we have assumed that a plus bx plus cx square plus dx cube plus e x to the power 4. Let me take some more, f x to the power 5, and this is an infinite series. Okay, now so we have to differentiate this f of x. Okay, let me do another thing. Let me find what is f of 0. So if x is equal to 0, so these terms will be equal to 0, right? And only the first term will remain a, because if you take x is equal to 0, this full term will be equal to 0. Okay, now let's differentiate this thing, f prime x. And if I differentiate this function, this coefficient will be equal to 0, so the first term will be b into 1, then c into 2x, then d into 3x square. Then you have to differentiate this thing. Okay, we have to do differentiation a lot, but after all you will find the pattern. Okay, so you have to see the video gradually to understand the pattern. Now again I need to find the function when x is equal to 0, so f prime 0. So this is simply is equal to the first term b into 1, because this term will be simply equal to 0. Okay, and then I need to differentiate it again, f prime prime x. So if I differentiate this, first term will be equal to 0, second term will be 2 into 1, third term will be 3 into 2x, then fourth term is 4 into 3x square, then this term will be 5 into 4x cube. Okay, and now if you take again here x is equal to 0, then only first term will remain, and this term will be equal to 0, so you will get c into, okay, wait a minute, what is 2 into 1? This is simply is equal to 2 factorial, right? So I have written here 2 factorial, and you will understand a pattern if I write this as 2 factorial. Then if I differentiate it again, first term will be equal to 0 as it's constant, second term will be d into 3 into 2 into 1. See, this is 3 factorial. Okay, now 4 into 3 into 2x, then 5 into 4 into 3x square. Okay, now if I take again here x is equal to 0, only first term will remain, so this is actually 3 into, sorry, d into, this is 3 factorial, right? So we have to write here 3 factorial, and I think you understand the pattern. So this is actually 1 is also equal to 1 factorial, so 1 factorial, 2 factorial, 3 factorial. You can say that the fourth term will be equal to what? Here you have d, so another, the next coefficient is e, then you should write here 4 factorial, right? Let me check this is actually true or not. Let me check. Let me differentiate this again. So I will get here, this term will be equal to 0, so 4 3 2 1, then 5 4 3 into 2x. We are checking that our answer is right or wrong. Okay, now if you take again x is equal to 0, so the first term is e into 4 factorial. See, e into 4 factorial. So let's don't do any further differentiation. You can easily say that this is 5 prime is equal to f into 5 factorial, right? So to match the series, I can write here, you can say that is a is equal to actually a into 1, and what is 1? 1 is equal to 0 factorial, right? To match the pattern, I have write here 0 factorial. So 0, 1, 2 factorial, 3 factorial, 4 and 5 factorial, and it will goes on and goes on. Okay, so now let me put these values in this series. Okay, so let me copy this thing. Let me copy this series and paste it here. Okay, now let's see. It's f. Okay, so what is a? From here I can write that a is equal to f of 0 by 0 factorial. Then, and also I can write here what you have a 1 here, right? You can write it is 1 here, and 1 is equal to x to the power 0, right? We can write this to match the pattern. Okay, now what is the value of b? B is equal to, from here I can write f prime at the denominator 1 factorial, then x to the power 1. Just try to understand the pattern. Then what is the value of c? C is equal to f double prime. As you have write double prime here, at the denominator you have to write 2 factorial, then x square, then f triple prime. So triple prime, that's why 3 factorial, and here x cube. Then f, if you want to find this, so what is e? Okay, let's don't focus here. You have understand the pattern. If I write here 4 factorial, so I have to write here 4 factorial and then x to the power 4. So what is the next term? If you write here 5 factorial, so you have to write here 5 factorial and then x to the power 5. And similarly, if you write here, if you differentiate it n times, so you have to write here n factorial and here x to the power n. So this is the pattern, and as it is an infinite series, so yes, we have to write dot dot dot. So this is the MacLaurin series, and using this series, let's find something. Let's say we want to find, let's say f of x is equal to e to the power x. Okay, let's say f of x is equal to e to the power x, and you can write this thing like f of 0 by 0 factorial into x to the power 0, and then you can write f of 1 factorial x to the power 1, then f of 2 factorial x to the power 2, and dot dot dot. Okay, so let's see. So let's we have to now find f of 0. So what is f of 0? So it's simple, e to the power 0 is equal to 1, right? Now we have to find this. So what is f of 1? Let's first define wait, this is what I have done here. This is actually f prime 0, and this is f prime 0. Okay, that means I have to differentiate e to the power x. So if I differentiate it, I will get e to the power x, and if I take x is equal to 0, I will get 1. Then again, if I again differentiate it, I will get again e to the power x, and if I put the value of x here, I will get 1. If I again differentiate it, I will get e to the power x, and if I put x is equal to 0, I will get 1. That means all these things are is equal to 1. So we can write e to the power x is equal to, so this is 1 divided by 0 factorial, 1 divided by 0 factorial x to the power 0, then this is 1, so 1 divided by 1 factorial x to the power 1, and then this is 1 also, 1 divided by 2 factorial x square. So simply the first term is equal to 1, right? See, 1, simple. Then this term will be x to the power 1 divided by 1 factorial, then this is x squared divided by 2 factorial. And by observing the pattern, you can write the next term, it is x cubed divided by 3 factorial. By watching the pattern, you can write it x to the power 4 divided by 4 factorial, and it will goes on for infinity. So let's now find sin x. Okay, let's see what is the value of sin x. Let's take f of x. Let's take f of x is equal to, let's write it here. Let's see f of x is equal to sin x. Okay, so to find the series of sin x, you need first f of 0, then f prime 0, f prime prime. That means you have to differentiate this function. So let's differentiate it. So this is f prime, sin x is equal to cos x, then f prime prime, this is minus sin x, then f prime 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 minus cos x, then 1 2 3 4, it's equal to sin x. Okay, let me take some more. Let me just differentiate it twice. This is 1 2 3 4 5, this is, let's say, cos x, and 1 2 3 4 5 6, this is minus sin x. Okay, so now I have to put this value here. I can write sin x is equal to f of 0 by 0 factorial x to the power 0, then f of 0, f prime 0, 1 factorial x to the power 1, then f prime prime 0, 2 factorial x square, then f triple prime 3 factorial x cube. Okay, if I need this, I will write it later. Okay, now let's write what is f of 0. You see, f of x is equal to sin x. So f of 0 is 0. The first term is 0. The first term is 0. Now what is the second term? F prime x is equal to cos x. So that this term is cos 0 degree is 1, right? So 1 by 1 factorial x to the power 1. Then f prime prime. So f prime prime, if you take here 0, this thing will be equal to 0. So this is also 0. Then triple prime. So triple prime is equal to minus cos x, and if you take here 0, so minus cos to the power 0, that means this is minus 1. So minus 1 by 3 factorial x cube. Okay, let me work some more terms that so that you can understand the pattern. Then let's take here 4 primes, 4 factorial x to the power 4, then take here 5 primes, 5 factorial x to the power 5. Okay, now let me see. So now I need this f4 prime. So what is f4 prime? Oh, it's also equal to 0. So this is equal to 0. Now let's take 5 prime. Okay, so what is f5 prime? So this is the 5 prime. So f5 prime is equal to cos x. So if you take x is equal to 0, cos 0 degree means 1. So this thing will be equal to 1. Okay, I think now you have understand the pattern. Okay, so I think now you have understand the pattern. So sin x, first of all you have to write here x, then 1 by 3 x cube divided by 3 factorial, and then plus x to the power 5 by 5 factorial. So you have to write here first plus, then minus, then plus, then again minus x to the power 3 5 7, the odd numbers. You see here is 1 3 5 7, then you have to write here x to the power 9, then you have to write here x to the power 11, and plus minus plus minus plus minus, and it will goes on. Okay, so this is the function of sin x. Similarly, if you find cos x, let's find cosx. So what will be the cosx? It's simply first 1. Okay, then you will get 1 minus x squared divided by 2 factorial. Here you have the even numbers. Now you have to write here odd numbers. Then x to the power 4 divided by 4 factorial, then minus x to the power 6 by 6 factorial. So I think you understand the pattern. X to the power 8 divided by 8 factorial. Okay, let's now see one thing. Do you know what is cos x plus I sin x? I think you know that cos x plus I sin x is simply is equal to e to the power ix, right? Let me prove this thing in this video, though it's not the topic of this video, but I don't know why I'm intended to prove this thing. So let's prove it. Okay, cos x plus I sin x. So let me first write the value of cos x here. So cos x is equal to, let me write it like this. So 1, okay, then minus x squared divided by 2 factorial, 1 minus x squared by 2 factorial, then x to the power 4 divided by 4 factorial, then minus x to the power 6 by 6 factorial. So this is the value of cos x. And now let's say I need to find the sin x. So what will be the sin x? Sin x, I will write this sin x, let's say it's I sin x in red color. Okay, so okay, so what is I sin x? So if I put here I, so I will get ix, and then if I put here I will get minus I x cube by 3 factorial. Then if I again put here I will get I x to the power 5 divided by 5 factorial. Again if I put here I will get minus I x to the power 7 by 7 factorial, and this will goes on and goes on. Okay, now let me rearrange this thing. Okay, so let me rearrange this thing. So this is 1, okay, it's 1, it's ix, okay, this ix, let me write here just 1 factorial, just to match the pattern. You will see why. Okay, so here you have minus 1. Can I write minus 1 is equal to I square? Yes, I square is equal to minus 1. So let me write here this minus is equal to I square. That means I square x square, and I can write this I square x square is equal to I x whole square. Then I square is equal to minus 1. Then this is minus I. So what is actually minus I? Can I write I cube is equal to minus I? Yes, I can write this. So I can write here I cube, ix cube, then 3 factorial. Why? Because I cube is equal to minus I. Then what is the value of I to the power 4? This is simply is equal to 1, right? We know that I to the power 4 is equal to 1. I to the power 4 is equal to 1. So I can write here I to the power 4. So ix to the power 4 divided by 4 factorial. Then I can write here I to the power 5, because I to the power 5 is equal to I. So ix to the power 5 divided by 5 factorial. And I think you understand the pattern. Let me don't write these two terms. Okay, so now tell me what is this. 1, then ix divided by 1 factorial, ix square divided by 2 factorial. Let me check what was e to the power x. Where is e to the power x? Here. You see, e to the power x looks like this. And let me compare these two terms. Let me compare these two terms. Let me copy this thing just so that you can understand it. Okay, so this is, let me copy this thing here. Okay, let me, okay, Okay, so this is e to the power x, and what will be this will be equal to, my notepad is hanging. I don't know what is the problem. Okay, this is actually e to the power ix. Okay, I don't know. Oh, okay, so this is actually e to the power ix. So this is actually e to the power ix. So I can prove that cos x plus I sin x, this is e to the power ix, and this is the Euler's formula, right? So I have proved this in this video. I don't know why I do this, because it's odd topic, but it's okay. And my notepad also. Okay, so see you in the next video. Bye.